The following is a production of the Washington Talking Book and Braille Library, a program of the Washington State Library, a division of the Office of the Secretary of State.
So, ladies and gentlemen, Thor Hanson.
Thank you. Thank you. Now we'll make sure I didn't leave my talk on the plane, but it looks like it's here. Hello, everybody. It's nice to see you all.
Nice to see you too.
Excellent. I'm glad you're here, and I'm glad to be with you. Thank you for the nice introduction, David. And it's fun for me to be at this library because there are some certain memories coming together for me at this very moment in chatting with John and reading, looking at a few pictures on the walls. And when I was a kid, my grandmother had lost her sight in her elder years, and so she used to get these books on, these sort of bizarre big old tape deck thing, dedicated thing that came in the mail, and she would get books on tape. This was back in the 70s, late 70s probably, early 80s. And there's a picture of one of those things out in the hall there. I thought, oh my God. So I have these early memories of listening to books with my grandmother all the time that we were getting from you guys or the national system, whatever it was at the time. She got them through the mail. And that really was part of how I learned to love books. Now, I mean, it's not that my taste as an 8-year-old matched my grandmother's taste as an 84-year-old. I'm sure there were some things that were over my head, and I may have been more interested in pushing the buttons on the tape machine than I was in what came out of the speaker. But I really remember then learning to listen to books and loved listening to books at the very same time that I was learning to love reading books. So that has always been a part of my experience, and I think that it really informed a habit that I've really developed over the years in my writing. And that is, I always read my writing aloud, constantly, while I'm writing. I'm always reading it aloud because it's the best way I know to identify the rough spots. And also to, hone your voice as a writer. I mean, people are always saying, oh, it's your writing voice. And I've always thought to myself, well, we've already got these perfectly good voices we use all day long. So why don't we read our work out loud more and develop our writing voice from our speaking voice, which I think really highlights, the different ways we can appreciate words and echo the long tradition, the long oral tradition of storytelling, which is where all of our stories and books and everything came from in the first place. So this is all coming together for me at this very moment, walking into the Talking Book and Braille Library. So thank you for bringing me some fun memories already today. Now, speaking of stories, when David first contacted me about the visit today, we thought it might be fun to draw on the breadth of my work rather than feature one particular book. And that sounds great. But it wasn't until I sat down and really started looking things over that I realized what that meant. That meant that I'm here today to tell you about the birds and the bees and the flowers and the trees. I couldn't believe my career has been summed up by a 1960s pop song, but nonetheless, you're all here and so am I, so we're going to go for it anyway. I know I'm in good company because you must be fascinated then by these same topics that I am. Now, as a biologist, as an author, I have of course spent a lot of time focused on plants and animals, but I also think about people a lot, more than you might expect, because my goal and my hope with my work really is not just to learn about the natural world, but to help people connect with it. And I've really come to think of this job as the storytelling of science, which often gets overlooked, but I think is vitally important to what we do as scientists. And like anyone who writes about nature, I owe a certain debt in style and in inspiration to a man named John Burroughs. And I don't know if anyone's heard of John Burroughs, but he was a nature writer over 100 years ago, late 19th century, early 20th century. who, in addition to all of his other accomplishments, if you've ever seen a picture of him, he managed to grow what may be the greatest beard in the history of nature writing. And I want to tell you, there is some stiff competition in nature writing. Not from me, mind you, but there's some stiff competition among nature writers for growing a good beard. This guy had it down. But believe it or not, at that time, Burroughs was one of the best-selling authors in North America. He sold more than 2 million copies of his books during his lifetime, and they're still in print. But just during his lifetime, more than 2 million copies of his books. And that was at a period of time, and of course the population was smaller, the reading population was smaller. So, relatively speaking, that sort of puts him in the league of someone like a Danielle Steele. Really hot, best-selling author. But of course, he didn't do it, with books titled, Betrayal or Season of Passion or something. No, his books were titled things like Leaf and Tendril, Bird and Bough, or my personal favorite, Squirrels and Other Fur Bearers. I mean, I would love to see the look on my editor's face if I pitched that title in the 21st century. But at the time, this was hot stuff. And he not only sold a lot of books, he had real influence with the politicians and the power brokers of his day, the titans of industry. Henry Ford liked his work so much, he used to send John Burroughs a new car every year. Burroughs went on vacation with the likes of Thomas Edison, Harvey Firestone. They were not only fans of his work, they were his friends. So what has changed? I mean, what's different today? I'm a nature writer, but I guarantee you that I am not vacationing with Warren Buffett. I can tell you that Elon Musk has yet to send me a new car. I keep waiting and waiting, and it's not happening. Well, Burroughs always credited his love of nature to his upbringing on a farm. And I think it's no coincidence that Ford and Firestone grew up on farms too, while Edison hailed from a town of fewer than 1,500 people. During that era, during Burroughs' lifetime, the vast majority of Americans, and presumably American readers, had roots in rural landscapes. They grew up on farms or in small towns, or they had family there. So to all of them, the topics of natural history were familiar topics. And so these books were popular. Today, on the other hand, for the first time in history, more than half the human population is living in cities, and that proportion is growing rapidly. We are becoming, for all intents and purposes, an urban species. And even those of us who live in rural areas, the way my family does, live a lifestyle that's pretty far removed from much of the rural tradition. I mean, we still drive to the grocery store to buy food or drive down to the coffee shop when we need a jolt of caffeine. And of course, we all have our digital devices connecting us to everything from stock quotes to tweet storms. And though we do keep chickens in my family, we have a nice flock of hens. I will freely admit to you that when that first batch of hens sort of started getting on in age, we dreaded the idea of putting them in the stew pot. So it was actually sort of a relief when a fox got the lot of them. And we didn't have to worry about the old axe and stump routine. So we are growing more distant from nature as a society. And I know of no better proof of that trend than a simple list. It is a list of the words deleted from recent editions of the Oxford Junior English Dictionary, which is the finest compendium of English designed specifically for young readers. Now, that list of words includes acorn, buttercup, bluebell, brook, chestnut, clover, dandelion, fern, gooseberry, minnow, heron, kingfisher, raven, poppy, tulip, willow, walnut, and lark, among many others. So of course, by removing these nature words, we are in a sense telling our children that such terms are irrelevant, that they won't need these words to talk about and to describe their world. Of course, the dictionary is making room for new words, words that better reflect our increasingly indoor, technology and media-focused lifestyles. New words like blog, broadband, celebrity, database, voicemail, bullet point. And I don't know about all of you, but when bullet point replaces buttercup in the dictionary, my alarm bells start to go off. But of course, as the dictionary's editors say in their own defense, it is a living and changing language. And the dictionary reflects the society, not the other way around. But there is one nature word, if you will, one word that was added to the most recent edition specifically for its relationship to the natural world. It's an adjective we've all heard, and that word is endangered. So I think it would be a mistake for us to believe for an instant that the omission of nature words and the addition of endangered are unrelated events. But while as a people our daily interactions with and familiarity with nature have diminished, it's my firm belief that we are all naturalists at heart, even city dwellers. I mean, after all, another stalwart in the John Burroughs social circle and fan club was none other than Teddy Roosevelt, who was born and raised in the middle of New York City, and yet, as president, went on to set aside over 230 million acres of national parks, national forests, and national wildlife refuges. So no matter where people are from, I believe we all share a basic instinctive affinity for the natural world. We, in a sense, are born to it. I tell people all the time, if you want to see more frogs and salamanders and spider eggs and seeds and things on a nature walk, don't take field guides, take a child. They're great. Borrow one if you don't have one. I suggest one about yay big. 4 years old, 5 years old, fabulous. Their center of gravity is way down here, so they've got a different perspective. And they also see more in nature than we do. They see more not only because they're low down, but because they have yet to develop the full suite of filters that we all use to block out information. Now, those are filters that we need just to get through a day in a world where everything is designed to grab our attention. I mean, try to imagine walking down the street without any filters in place. It's actually a serious sensory disorder not to have those filters as an adult. But kids are still developing that system, right? And so they can see more in nature and we can learn something from them, because those filters, I'm telling you, they are going to block out the song of a warbler just as easily as they're going to block out somebody's annoying ringtone. So we can learn something from kids by getting out in nature with them. And should you doubt for an instant that kids have this ability and they have this interest, and we all do, I mean, all you have to do is do what my family did not too long ago, and that is go to the Woodland Park Zoo in the middle of spring break. Have you ever tried this? It is a full contact sport. In the middle, every child in the greater Seattle area is packed into that zoo during spring break. I mean, what do kids do when they get time off? They go and they look at animals. Now, with our species rapidly urbanizing, and with all the glittering distractions of the modern world clamoring for our attention, we need to be able to find the nature around us wherever we happen to live, and the storytelling of science can help us to do just that. To that end, I am particularly fascinated by natural objects that transcend the imaginary, but nonetheless very significant boundary that we erect between the human world and the natural world. I mean, wilderness areas and national parks and all are spectacular, but they're usually distant. You know, visited only occasionally by many people, or by some people, not at all. Yet in our daily lives, we're still surrounded by natural things. Things like feathers, things like seeds and bees that are filled with stories. I mean, we never stop to think about the buzzing in a shrubbery, or the down feathers inside of our pillows, or the poppy seeds in a piece of cake. But when we do take the time to pause and investigate, we find that these common wonders can be touchstones to the natural world. They tell us incredible stories about evolution and biology, about nature, and about our connections to it. Now, I'd like to tell you several of those stories today, beginning with one about the evolution of feathers. It is a marvelous story, and like a lot of great stories, it all started in Kansas.
Oh, I remember that. That was like Dorothy and Toto.
You got it. Yes, another Kansas story for you here this afternoon. So,
Wizard of the Oz, or something like that. Wizard of the Oz.
you got it right on. Wizard of Oz. And
The wicked witch, wicked witch, wicked witch.
you got it. No, that's exactly right. And this is another fabulous story from the same neck of the woods. Now, for decades, the standard theory of feather evolution went something like this. Feathers evolved from scales that slowly elongated and frayed from the edges until they looked something like a feather. That was in the textbooks when I took ornithology, which wasn't that long ago. But then in the early 1990s, there was a young professor named Richard Prum teaching his first year of Ornithology 101 at the University of Kansas. He's at Yale now, but this was when Rick was first starting out. And like some people I've heard of, he was preparing his lectures the night before giving them. Shocking idea. But he wanted to teach his class about how feathers grow, right? Which seems like a logical topic for an ornithology class, but oddly enough, it's not taught very often. It's a very complicated helical process that all occurs within this feather follicle. It's complex stuff, and it's not even really there in detail in those textbooks. But he got out all of these old papers and old texts and stayed up late at night, and he figured this thing out, and he wrote his lecture, and he gave the lecture the next morning. And then, by God, Wednesday rolls around, and he needs another lecture. So he was up at the chalkboard, and he was giving his sort of standard feather evolution lecture. That old story I was just telling about the scales and so forth. And he realized that it didn't make any sense, that you can't get there from here. He told me he had his aha moment at the chalkboard in the classroom. And what he realized in that moment was this, that feathers and scales are so different in the way that they grow that they must have been on different evolutionary pathways. Now, a scale is what they would call a ridge of epidermal tissue. You can make an incipient scale right now and I invite you to do so on your hand by just pinching the back of your hand. Just pinch that skin between your fingers, and what you will have there is basically something like a scale. And if you do that, what you can immediately see is that both the top of your scale and the bottom of your scale are made from the outside of your skin. But a feather is inherently tubular. It's much more like your finger, a tube surrounded by epidermal tissue. Now, it may flatten out and cover the surface of an animal in the way that scales do, but feathers flatten in a totally different way. They flatten by unfurling, right? So now imagine unfurling your finger. Split it down the bottom and unfurl that thing. Well, after you clean up all the blood and mess, what you would notice then is that the top of your feather finger would be made from the outside of your skin, but the bottom would be made from the inside. And that means that the structure of a feather and the structure of a scale are different. They are not what biologists would call homologous. They're not the same, and that means they evolved differently. So what I love about this story is that it shows the power of teaching in a way, and the synergy that can happen in a classroom. Because what Rick did then, over the next several years, was make it a project for his ornithology classes to come up with a better theory of feather evolution, right? He asked the question, what are the evolutionary novelties, the inventions that you must come up with to grow something as complex as a modern feather, a modern plume? It doesn't just spring fully formed from the thigh of Zeus. I mean, first you have to be able to make a tube. You have to make a tube of epidermal tissue. You have to split that tube into filaments. You have to organize those filaments around a central shaft, the rachis, and then you have to somehow connect all of those filaments together to form a vein. And all of those steps need to happen in that order before you can make something like a feather. So this developmental theory of feather evolution came to be in a classroom in Kansas. And it would have stayed there. It would have stayed in that classroom if Rick hadn't happened to have had a Chinese exchange student one year. This is late 90s. And this exchange student was actually in the paleontology department, but he had signed up for an ornithology class because he had an interest in birds. And after they got through this lecture and project, he came up to the front of the room and he virtually begged Rick Prum to publish this theory. Because what he knew at that time that Rick didn't was that the developmental theory of feather evolution was going to be crucial for Chinese scientists in understanding and explaining this great trove of feathered dinosaur fossils that they were at that time uncovering in northeastern China. So in what must count as one of the best ever examples of scientific serendipity, Rick went ahead and published this theory at the very same moment that the fossils to prove the theory were being uncovered and published in China. And if you open up an ornithology textbook now, you will see this theory now fully illustrated by these marvelous fossils from China, particularly within one group of fossils, the theropods, which include the meat eaters. All of these steps of feather evolution are now clearly in evidence, from the quill to the fuzzy, what they're calling dino fuzz stage, and then all the way up through aerodynamic feathers within those theropods, which include everything from, Allosaurus to the dreaded velociraptors from Jurassic Park, even Tyrannosaurus Rex. Rick told me his kids were young at that time. He had two boys who were big dinosaur fans, and he said I had to sit them down and have a real heart-to-heart talk. Said, guys, I hate to tell you, but Tyrannosaurus Rex had feathers. They're like, no way, Dad. They didn't want to hear it. And of course, all the t-shirt makers and the toy makers now have a big task ahead because they have to redesign all of these ferocious-looking dinosaurs to look a lot more like chickens. So after I finished this book on feathers, I embarked upon an exploration of seeds. And my wife made a very interesting observation, because my first book had been about mountain gorillas and some work I did in Africa. And then I wrote a book about feathers, and then I was writing about seeds, and she said, your topics keep getting smaller. You're going to write yourself out of a job. What's next, dust motes? Fair enough. But I've learned along the way that the size of an object has no bearing upon the wonderful stories one can tell about it, or upon its importance in our lives and in nature. And seeds, fit that bill to the T. I mean, they're fabulous. I'm on my way back now from the Global Seed Symposium, so if I geek out on seeds, you'll have to excuse me. At any rate, consider just one basic characteristic of seeds, their endurance, right? The ability to lie dormant in the soil for months, years, even decades before sprouting. I mean, we take it for granted that we can go down to the hardware store and buy a packet of seeds, and then if we forget to plant them that spring, wait a year or so, well, they're probably still good. You can still plant those bloody things. We take it for granted that staple grains like wheat and corn can be stored in a warehouse over in the Palouse for a year or more before the market opens up and they finally sell them. Our farming systems, our food systems, all depend on dormancy. But biologically, it's still a very mysterious trait. How does a baby plant enter what amounts to a state of suspended animation and then spring to life again exactly when the time is right? Experts still aren't sure. It's really quite a mystery, but they think it has something to do with a substance called bioglass. Now, we know that truly dormant seeds are desiccated. They dry out. They lose, each individual cell will lose 85, 90, even 95% of its water. And what's left inside those cells, the nucleus and the various organelles that make a cell function, are encased in this sugar-based glass-like substance that somehow preserves not only their function and their form, but also a memory of arrangement. So that when that cell is flooded again with water at the point of germination, everything goes back into place and begins functioning normally as if no time had passed at all. So what I can tell you is don't try this at home with your cells, because animal cells can't do this. If you dry out your cells and reflood them again, you will not be functioning normally. But seed cells know how to do this. They can pull this off, and they do it all the time. We take it for granted. And even though we don't understand exactly how it works, scientists are beginning to use that idea in other contexts. My favorite is the example of the world's first dry vaccines. Right? Vaccination in developing countries has always been a challenge when you get out beyond the point where the ice in your ice chest melts out in some hot landscape, and all of your live vaccine perishes, right? So there have always been places beyond where we can easily get to that have been troubling to vaccinate. So this idea of a dry vaccine where you wouldn't need to refrigerate it has been a goal for a long time in medical circles, and they finally figured out how to do it by extracting one of these bioglasses, a sugar-based thing called myo-inositol, from the seeds of various plants, including rice and some certain nuts, and then suspending the vaccine within that bioglass so that it can be stored fully alive for up to 6 months with no refrigeration whatsoever. And this has greatly changed the way we're going about vaccinations out in remote landscapes. So fabulous stuff, but all of it really invites sort of an obvious question. Okay, seeds go dormant. They endure for a long time in the soil or forgotten in the back of your garden shed. How long can a dormant seed last? Now the answer to that is a fabulous story, and it comes to us from a place called Masada. And in case you missed the miniseries in the early 1980s, it starred Peter O'Toole and various others, several nights in a row there on ABC, Masada is an ancient fortress perched up on a rocky crag right on the edge of the Dead Sea. And it's a famous site because at the end of the Great Revolt, there was a band of Jewish rebels who held out in that fortress for months on end while they were completely surrounded at the base by a full legion of Roman soldiers. And when the Romans finally breached the walls of that fortress, they built a ramp all the way up the side and moved their machines up and breached the walls. They found that the rebels inside had committed mass suicide rather than surrender to the Romans. So this is a very important cultural site in modern-day Israel, and as such has been thoroughly excavated by archaeologists beginning in the 1960s. And they found all this incredible stuff. They found coins, and they found weapons, and they found whole troves of foods that were still there and still in remarkably good shape, including a bunch of date pits that were so well preserved there were still bits of date flesh, the fruit itself, clinging to the edges of these pits. And this was particularly important because these were Judean dates. These were Judean dates, which is a famous fruit mentioned in the Bible. And in all sorts of ancient writing, it was the major cash crop of King Herod's kingdom, this date. They grew them in Judea, and they exported them throughout the ancient world. The Emperor Augustus was famed to require them upon his table at all times, Judean dates. But they had disappeared. They had disappeared soon after the fall of Judea. People stopped growing them, and that whole variety was gone. It was a sort of a mythical variety of date, and here they were. So this was fabulous, and being good archaeologists, they put numbers on all of them and stuck them in a drawer. And then a few years ago, some botanists got a hold of several of these pits, and they planted them. Lo and behold, if one of those didn't sprout and grow into a perfectly healthy young Judean date palm after 2,000 years buried in the rubble at Masada. It's truly a remarkable example of how long, when the conditions are right, when it's dry and desiccated and dark under the soil there, how long a seed is capable of lasting. So, at any rate, it is now living. They've named the tree Methuselah for obvious reasons, and given it a nice little dedicated enclave on a kibbutz in southern Israel, and they're madly trying to germinate a female, because in the date palms, the males and female flowers are on separate plants. So this is a pollen producer. They're now trying to get a female to sprout so they can fully resurrect this ancient biblical fruit. But it's just absolutely remarkable. I mean, it's this wonderful symbol of endurance and mystery, and it's hardly the only example. I mean, we have a seed bank in this country, a massive seed bank in Fort Collins, Colorado, the National Seed Bank. And I visited that place and spoke with the director there. And she knows more about dormant seeds than just about anyone. I mean, she's taking care of 2 billion of them in the seed bank. So she knows a lot. And she told me something that was remarkable. She said that a truly dormant seed has no measurable metabolic activity. Now, in biology, we have a word for things with no metabolism. We call them dead. And I told her that, and she said something that I will never forget. She said, well, if we know of living things that aren't metabolizing, then maybe we need to change our definition of what it means to be alive. So the biology of something as common as a seed can challenge our very notion of life itself. And dormancy is just one of their many fascinating traits. I could rattle off all sorts of stories here indefinitely, but I will sum up the seed portion of our discussion with a quotation that I love from George Bernard Shaw that I think captures the idea pretty well. He said, "Think of the fierce energy concentrated in an acorn. You bury it in the ground and it explodes into a giant oak. Bury a sheep and nothing happens. Nothing happens but decay." So my most recent book is about bees, another essential and often overlooked natural wonder. Now, bees have been on my mind for a long time, in part because of a story that I heard years ago, one that I think says so much about the relationship between people and nature. Now, this was in the mid-1990s, and I worked on a mountain gorilla project in a place called Bwindi Impenetrable Forest in southwestern Uganda. The job involved a lot of trekking in hot weather, and we were often set upon by these hordes of tiny little black flies. At least I thought they were flies until I looked closely at these things, and I realized that they were bees. Minute little bees, like the size of a pencil point, but perfectly formed and perfectly jet black. These were stingless bees, and there were at least 12 different varieties living in that forest, and I'd never heard of such a thing. Totally harmless little stingless bees, perfectly benign and marvelous. So there was a Ugandan graduate student at one point who came down to do his master's work on these stingless bees. And after a couple of weeks, this guy was tearing his hair out. I mean, he could sort of see his whole thesis fizzling out in front of his eyes because he'd been hiking through the woods day after day, been seeing bees, but he couldn't find the nests, and he had to find their nests if he was going to do this research project. So we suggested to him that he hire one of the Batwa pygmies who until recently had called that forest home and were marvelous, with their knowledge of all sorts of things living in the forest. So he thought that was a good idea, and he went and he hired this fellow to be his guide. And Vincent was his name, this master's student. He went out with this Batwa man, and they set off for a day in the woods. And he was telling me about this later. He said, they went hiking in to a clearing in the forest, and they saw some flowers, and they sat down. And they watched the flowers. And then sure enough, one of these little black bees shows up, futzes around on the flower for a while, and then zips off again. And they wait. And a while later, there's another bee. And this happens over and over again, and they've been sitting there a long time. And Vincent said, "Guys, what am I paying this guy for?" And finally, the man gets up. He said, "We go," and walks off into the woods. and they walk for, it's a dense thing, and they're going through the vines and so forth, and they get out there a certain distance, and then he slows down, and he starts to look, and he starts to look, and he starts to look, and he points to a stump, old rotten stump. He said, there it is, and here were the bees going in and out. And of course, what he had done was watch the bees coming to the flower. He knew the flower, first of all. He knew that's the flower that they're going to like. So he knew the flower to sit by. He saw the bees coming. He saw them leaving, and he knew what direction they were going. And he sat and he watched it enough times to know how long it took a bee to make a round trip. And once he knew that, that's all he needed. He had a direction, and because anybody knows how fast a stingless bee flies, he could do the math in his head, and he knew he just needed to walk a certain distance, and he knew that that species of bee nested in rotten logs and stumps. So he walked the right distance, looked around, there's the stump, there are your bees. What do you want? Piece of cake. Piece of cake. Tracking bees in a jungle. That now, it has always been, just to me, the pinnacle of natural history knowledge, something I will never attain. But I think it says so much about the history of our relationship with nature. Because I guarantee you we have a lot more tracking in our history than texting. And so when we learn about natural history then, it's not only new knowledge, it's an act of remembrance. This is our heritage, in a way, is to know nature well enough that you can casually track a bee. So bees are on our minds a lot these days because we're worried about them, aren't we, right? I mean, you hear about bees now in the news a lot more than you used to, right? You hear about horrible stories about honeybee colonies collapsing en masse and steep declines in many native bees. All of these things. And in reading those stories, though, I have often noticed a certain, mushiness about the subject matter. I mean, what do we really know about bees? Even the experts sometimes stumble over the details, right? I was driving in my car not too long ago, listening to National Public Radio, the source of all knowledge, and they were interviewing a very noted historian of science. And he was going on about how when the settlers arrived at Plymouth and Jamestown, they brought honeybees with them from Europe, which is true. The honeybee is native to Europe and Africa. It's not a North American bee. And then he went on to say if they hadn't, there would have been nothing here to pollinate their crops. And I almost drove off the road. What about the 4,000 species of native bees already buzzing happily around this continent? I couldn't believe it. But believe it, that's not the worst of it. That's not the worst of it. Given my interests, it probably will not surprise you to learn that I keep a copy of the book Bees of the World in my office. It's a nice reference book, written by a couple of good entomologists, and a nice hardback edition, good press, the whole bit. And the cover features this lovely close-up photograph of a fly. A fly on the cover of Bees of the World. I mean, what's it coming to? So here in the 21st century, we find ourselves in this really peculiar position of being more familiar with the plight of bees than we are with the bees themselves. Which I think means that the logical place to start in any exploration of bees is right at the very beginning with the question, what is a bee? And I'm happy to report that I can share with you an answer this afternoon that is short. I hope it's memorable. I think it is. And it really does sum up all the key steps of bee evolution. A bee is a hippie wasp. All right, now let me explain. The first thing to know is that wasps came first, right? Wasps came first, and they've been around for millions of years before bees came along. Bees evolved from the wasps, and they still look quite a lot like them, which is why the two groups are so often confused. But if you are being harassed at a picnic and you find your little buzzing attackers hovering around the fried chicken or stealing pieces of bologna from your sandwich, then don't blame bees. Your attackers in that situation are certainly wasps, because wasps are carnivorous. Well, probably, technically they are omnivores, but they love meat, right? So they will be collecting bits of meat or out constantly hunting through the landscape to find other insects to attack, or spiders, caterpillars, all sorts of things that they will sting and take home to feed to the larvae, the baby wasps, back in the nest, right? But bees gave up that lifestyle. They gave up that lifestyle and learned to provision themselves and their offspring solely from the products of flowers, right? They made this change that set them apart from the wasps, put them on their own evolutionary pathway, and their bodies and habits began to change in adaptation to that new lifestyle. So they evolved long tube-like tongues for sipping nectar. They evolved these marvelous long hairs that are branched like a feather, specifically adapted to carry more pollen from those flowers back home to the nest. Now, there is, of course, nuance to this whole story. Evolution is complicated. There are some bees that are parasitic, and they don't bother collecting pollen. There are some wasps that like to visit flowers and sip at nectar. They're happy to have some nectar to go with their bologna sandwich. But if you want to remember the basics of bee evolution, you just remember that they are the long-haired, flower-loving vegetarians. They are the hippie wasps. Now, all of this evolutionary activity took place quite a long time ago. Bees have been with us for at least 120 million years, since the middle of the Cretaceous period, which was a point in time famously dominated by those dinosaurs we were talking about earlier. But if you can look past those lumbering beasts for a moment the next time you see one of these movies, take a look at the vegetation, because there was a lot going on in the vegetation 120 million years ago. That was right at the point in time when flowering plants were just beginning to diversify and spread across the face of this planet. And bees evolved at that very same time. So that what you see is the diversity of one influencing the diversity of the other. But this was unknown. This was a mystery, right? Early naturalists were totally baffled by what they saw in the fossil record, because they saw this situation where there were no flowering plants, and then, bam, flowering plants were diverse, they were everywhere. How did this happen so quickly, right? Charles Darwin considered this one of the greatest threats to his idea of evolution as a slow and incremental process. Where did all these flowering plants come from? He famously called it an abominable mystery, right? But in the same letter where he made that comment, he went on to refer to his correspondent with a much lesser-known naturalist of the day, a Frenchman named Gaston de Saporta, who had theorized that flowering plants did indeed evolve rapidly. It wasn't a mystery. They evolved rapidly because they were interacting with the flower-visiting insects, particularly the bees. And he and Darwin had corresponded about this, and Darwin wasn't buying it. Darwin didn't buy it. He preferred to think that the flowering plants must have evolved slowly and incrementally somewhere else and then dispersed rapidly to the places where they became fossilized. Well, Darwin had a much bigger reputation at that time, and he also, bigger reputation and a bigger beard. The beards keep coming up, but naturalists have always had beard competitions, and Darwin, he was no piker. So anyway, people listened to Darwin, and they did not listen to Saporta for decades and decades until the turn of the century, when they had done enough research to realize that Saporta had been right all along. And it was this co-evolution between the bees particularly and other insects and the flowering plants that drove this diversity. And now you can see the results of it anywhere from a meadow full of wildflowers to a flower market, this incredible diversity of flowers that we have as a result, so that it's, the flowering plants now dominate the flora of this planet. But what is less well known is how that same interaction drove an incredible diversity of bees. I mean, which range from the familiar, like the honeybee, or even a bumblebee we may be familiar with, but to the fantastic, like those little black stingless bees, or these iridescent sweat bees. You can see them in the landscape here. There are bizarre bees from the Atacama Desert that have tongues twice as long as their own body, adapted to sipping the nectar from specific long-tubed flowers in that region. There are bees that can be minuscule, smaller than a pencil point, or they can be massive, as big as Wallace's leafcutter bee, which would cover your whole palm, and is only known from a few specimens out in the islands of Indonesia. It lives up in the canopy, makes its nest inside of termite mounds. Rarely seen, only recently rediscovered. They thought it was gone, but it's still there. So the coevolution of bees and flowering plants has led to great diversity on both sides of that equation. Then now there are a full 20,000 species estimated of bees in the world, which is more than all of the birds and mammals put together. You could even add in the snakes, and there'd still be room to spare. There are a lot of bees in the world, maybe thousands yet to be named. It's not out of the question. In fact, perhaps it's even likely that even in a well-studied landscape like Puget Sound, we might be sitting here a few miles from a bee unknown to science. Totally thrilling. So if I were giving this presentation 100 years ago, I would simply stop and take your questions. Even 50 years ago, I might not have needed to say another word. But in the 21st century, it's impossible to talk about natural wonders without confronting the challenges that they face. Because just as many bees are in decline, so too are 1 in 8 of the world's bird species threatened with extinction. So too are many seeds and the plants that they grow into suffering from habitat loss, climate change, dwindling crop diversity. These threats are real and they are daunting. And they make it all the more crucial for us to revitalize our connections to nature every day, because our resolve gains strength with wonder. We are stronger when we can meet these challenges, not from the standpoint of despair, but from the perspective of fascination. So I would like to conclude with a short passage from the latest book, from the preface to Buzz. It's from the beginning, but it's of course about bees, and it's the bee book. But I think the message of it is true to all of these common wonders we've been talking about. And I think it's important and appropriate to end at the start in a way, because we're still just beginning to understand the biology of many of these things. We're still just beginning to understand our relationship to them, our dependence upon them, and we're still just beginning to do what we can to help them. So this little passage comes from the preface to Buzz, and it begins with a lovely epigraph from Henry David Thoreau, who wrote, "There are certain pursuits which, if not wholly poetic and true, do at least suggest a nobler and finer relation to nature than the one we know. The keeping of bees, for instance, is like directing the sunbeams." Bees today certainly need our help, but just as importantly, they need our curiosity. Exploring the history and biology of these essential creatures can transform anyone into an enthusiast, and that is the purpose of this book. But I hope you will do more than read it. I hope it makes you want to go straight outside on the next sunny day, find a bee on a flower, and settle down to watch. If you do, you might just find yourself daring to reach out and catch that bee, the same way my young son has done since the age of 3, barehanded. Try this, and you too can feel the tickle of tiny feet and the whispery rustle of wings on your palm before you slowly part your fingers, hold the bee up, and set it free. Thank you so very much, and I'm happy to answer questions and whatnot at this point. Any questions at all about bees, seeds, feathers, writing, any of it? Yes?
How many species of bees in Washington State, roughly?
What a good question. We don't have a full list. that I know of, but you're talking about probably between I would guess maybe around 600, something like that. I did some work out in the San Juans where I live. And when you're sampling, and if you start putting things on a graph like scientists do, you sample the amount of time that you're sampling and the number of species. And what happens is the number of species goes up, and you spend more time in it, the number of species caps out because you found them all. And I got up to about 120 species, and I was still going up like this. And that's just in a very local area. So there are hundreds of species here. Some of the most diverse places for bees are a bit surprising. It's not the tropical rainforest, although there are plenty of bees there. That's the center of diversity for most insects and most flowering plants. But the happiest place and the most diverse place for bees is in deserts and semi-deserts, which is a little bit counterintuitive. So if you go down to a place like Arizona, you'll find well over 1,000 bees in that landscape. So the centers of diversity for bees are the desert Southwest. They are in the Mediterranean, over in places like Syria, Israel, down in South Africa and some of the dry country there. And bees thrive in those environments in part because the dry weather helps protect them from fungal diseases, which really hit bees hard in our neck of the woods. They spend most of the year, most bees are solitary creatures, not like these big hives full of honeybees that we're so familiar with. Most of them have a short period of activity coinciding with the plants that they visit, the flowers that they like. And then they make it's an individual solitary female. She breeds, and then she finds some flowers, and she makes a nest, and she lays her eggs, and the eggs sit there and eat the pollen and so forth. And then they hibernate in some fashion, either as pupae or as adults. They hibernate until the next season. That's the classic bee lifestyle. And so if you do that in a neck of the woods like this, in a climate like this, that whole period of time, which could be 10 months, when you're underground or you're stuck in a little hole in a tree or wherever it may be, you're nesting in the end of a twig, you can get wet and rot. So where you see bees really thriving is in these dry conditions where they have high survival and where there's good flower diversity, brief flowering periods, but abundant flowering during those periods, and abundant nesting habitat, because most bees nest in the ground. And in deserts and dry shrublands, you've got a lot of bare ground, great places for digging a hole. Whereas around here, a lot of plants in the way. So if you go out here in the springtime and you're looking for your first bee of the year, which is always an event in our family, the bee that you're going to see is a big queen bumblebee, right? And what she's doing is going back and forth over the ground like this. She's going back and forth and back. We can watch her all afternoon. She's going back and forth. She's looking for a hole, right? She's looking for a place to build a nest is what she's up to. So for bumblebees, it's just those queens that survive the winter. They mated in the fall, they've survived the winter, they come out, and then they start looking for a place to start a colony. So guaranteed bee sighting around here. Identifying bees can be tricky. But if you know a little about their biology, there are certain giveaways. And so first bee of the year around here is going to be a bumblebee. Also true if you are wearing a wool sweater and a cap down over your ears and you see a bee, it's a bumblebee, because they're very good at warming up their flight muscles and flying on cold days, where most bees and other insects have to wait for the sun and a certain temperature. So there are certain tricks to bee IDs. Sure, we didn't go into it specifically, but so honeybees are suffering from a number of maladies. Now this really gained attention in 2006 with the advent of something that was named colony collapse disorder. And it started occurring on the east coast of North America, and beekeepers who know more about, commercial beekeepers know more about taking care of honeybees than anybody. It's their business. And they started losing massive numbers of hives in a mysterious way. The hives would empty out. You'd go out to check your bees, and it would be empty. There'd be the queen in there and a few feeble-looking hive bees, and and the rest of the workers would all be gone, and the colony would collapse. So they started looking at this. The good news about it was how much research attention became focused on it. But after 10 years, the only thing that is certain is that it's more than one thing. And that is, it's not some smoking gun that started killing off these hives, but rather what they're more likely to call now a multiple stress disorder. And there are several of them that have been summarized as, the 5 Ps, which include parasites, pathogens, poor nutrition, include, how many P's are there? Anyway, a bunch of these P's. Habitat loss, and poor nutrition, which is sort of an odd one, but if you think about what a honeybee is adapted to eating, it's a very diverse diet of flowers in the landscape. So we have reduced the amount of flowers in the landscape and reduced their diversity, not only in wild areas, but also in the way we've changed agriculture over the last half century or 75 years. Going from smaller farms, multi-cropped, where every homestead probably had a kitchen garden and an orchard, and you had your crops. Maybe you had some animals too. Much more mixed farming. And we've changed from that to a more efficient means of production, but one that eliminated hedgerows from fields, that farms one thing over large areas. And even if that's a crop that is good for bees, like mustard, or it's almond flowers or apples or what have you, well, that's great, but it's only got food for 3 weeks while they're blooming, right? And then it's a desert for the rest of the year because we have wiped out the rest of the habitat. So it's counterintuitive, but sometimes you can survey for bees and find greater diversity in the suburbs and even in city parks than you can out in the countryside nearby. So we've done a lot to change the habitat, and bees are stressed from that, and then they're stressed from these other aspects of life, these other things like pesticides and so forth. So you have chemical stresses, you have lack of food, you have these horrible little mites that get on them that are native to South Asia and now are everywhere, and a lot of diseases, pathogens that are attacking them. So their health, it's really a crisis of bee health, right? And these things tend to interact. So it's often very difficult to tell exactly what might cause a particular bee decline, because you might have bees that have a disease that for a healthy bee would be like a head cold. But if the bee is already hungry, and if the bee is already weakened from fighting off some pesticide in its system, then that little disease wipes it out. Or maybe you've got a pesticide that's been thoroughly tested and bee safe, but you get it out into a field where there has been a fungicide sprayed, and it interacts with that chemical and becomes much more harmful. So the environment for bees right now is complicated and filled with a lot of stressors, and these things tend to combine in unpredictable ways to cause declines. The good news is that with short generation spans that bees and other insects have, and with enough knowledge about these stressors, there are things we can do as individuals and as a society to improve things for bees and see what is very rare in conservation biology, and that is instant gratification. I went out, I have a little bee garden in front of my office, and I went to the hardware store last summer or the summer before thinking, I need to get some of this catmint. Right? Catmint, this plant, Nepeta or whatever the genus is. Anyway, the purple flowering catmint, cats love it, catnip, I guess it is. At any rate, bees love it too. And you can just get it at the hardware store, and I'm going to get myself some of that to improve my bee garden. And before I could get the plants out of the pots and into the ground, I had 3 species of bumblebees on them, and I thought,
Yeah.
So by planting flowers, by eliminating or vastly reducing the use of pesticides in our yards and in our farming when we can, there are these simple, relatively simple steps we can take that really do have an impact on improving bee health and in providing nesting habitat, all these things. And there are programs going on in farmscapes as well that are showing real good results and benefiting farms as well by improving pollination and lessening our reliance upon only honeybees, which we've become very dependent upon by reducing overall bee diversity in agricultural landscapes. We're even more dependent upon the domestic bee, so when it's stressed, it makes things even more tenuous. So at any rate, lots of good news there mixed in with the bad. Yeah, so this is a great question. One of the challenges of climate change, it's creating timing challenges in that creatures respond in different ways and at different rates, and sometimes to different factors in their environment in terms of when they become active in the spring. So you might have a plant that responds very rapidly to change in temperature. It gets warm, the plant grows and blooms. You might have a bee that is influenced in part by temperature, but in part by day length. And day length, we're not changing the day length. That pattern is set in stone. And so you get what they call a timing mismatch, potentially, between these things. And so where it really comes into play for bees, or where the main focus of worry is upon specialist bees. When you have a bee like a honeybee or a bumblebee, or even some of the leafcutter bees, some of the mason bees that visit a wide variety of flowers, they're already used to looking for a lot of stuff. And so if the particular community of flowers that's blooming when they become active is a little different, they've got some flexibility. They've got some flexibility in their lifestyle. But you also have out there, among these 20,000 bees of the world, you have specialists, where they've evolved a particular relationship with a small group of flowers, or even with one species of flower, or very few. And that's where we worry, for the plant and for the bee. Those specialty relationships are, at the heart of biodiversity, really. When you have long, stable periods, it allows these marvelous specialized relationships to evolve, and they can be very successful, but they're less flexible, they're less adaptable to rapid change. And so we worry now about the specialists. In our environment here, if you go down to some of the grasslands down by the water in the springtime, you'll see, or even up east of the mountains, it's beyond there too. Any dry sort of grassy area around here will have a plant called death camas, which you may have seen as these beautiful, creamy, yellowish-white flowers. And in its vegetative form, it looks very much like its cousin, the blue camas. Blue camas is edible. People have harvested the bulbs of it for years, centuries, thousands of years in this neck of the woods. A very important food plant. Death camas, of course, is deadly poisonous. And it's a very strange poisonous plant in that the whole bloody thing is poisonous. Plants are usually a little more selective where they put their poison, right? I mean, they want to protect their leaves, so they poison that. They want to protect their seeds, they poison that. But not very many plants put poison in their pollen and their nectar, because it's generally a bad idea to poison the creatures that you're trying to use as pollinators, right? So bees benefit in a sense from this strategy of plants to lure them in with a sweet and nourishing and proteinaceous treat. So usually those things are fair game. But death camas is all poisonous, including the nectar, including the pollen. And so in our fauna, there's really only one bee that has evolved a way to detoxify the alkaloid that's in that poison, right? So we have the death camas bee. And the death camas bee is one of these specialists, right? It can visit a few other things, but it's really focused on death camas. And if you see a bee on death camas, it's almost always the death camas. The only other bee I've ever seen on death camas, there's a little flower beetle that'll get on there. I've heard of flies east of the mountain. I haven't seen the fly here. Anyway, but I did find a little cuckoo bee on death camas once. And it looked kind of like this. And I picked it up on my finger, and I was doing other stuff, so I put it on my shirt, and I carried it around for about a half an hour, and it was still absolutely out of its gourd on that nectar. So I put it back on a different flower in the sun, and said a prayer to the moon for that little character. So it had poisoned itself. Like, hey, good-looking flower. Bad idea. So the death camas bee is the only one around here that can do it. But that's the sort of relationship that we worry about, right? This disconnect that can happen. Because what's going to happen if their schedules diverge, which is happening with so many things. I mean, you think about birds that migrate based mostly on day length, and many of the insects or fruits and things and seeds that they're after may be responding to temperature. Some of these specialty relationships are at risk in all sorts of ways. Great question. Yes?
I had a family that used to live in I had a family, when I first came out here from Denver, I used to live in Denver for a couple of years. My mom came out, and one of the houses that we used to live in, we had like a plum tree, and we had an apple tree, and we had like blackberry picking out there where me and my girl would go up blackberry picking in the morning.
Isn't that fabulous? And all of that delicious fruit.
Delicious fruit comes where it grows. It just does all that stuff.
Yeah, and you get it pollinated by the bees.
It's in the stores. It's in the grocery store. You can just buy it like that. It grows. It grows in the ground. Some of it goes in the ground, and some of it grows in the trees.
And it brings together a lot of what we've been talking about, because you've got pollination, and then you've got all that fruit that's only window dressing for the seeds in there. I mean, fruit, the fleshy fruits evolved for the sole purpose of temptation. They were right on to choose that apple for the Bible story. That's the whole story.
Yeah, Adam and Eve.
Yeah. Because, they wouldn't have evolved if it weren't to try to lure animals like us into moving the seeds within from place to place. No other purpose for it. Yes, right there in the middle. That's a really good question, and I don't know of an example. Usually the pollen and the nectar are fair game. I mean, there are some poisons here and there, but usually what's more typical is for the structure of the flower to exclude unwanted pollinators. Yeah, I mean, from orchids to foxgloves to all sorts of different plants like irises. That the good stuff is all way down, and then you need to be heavy enough, like a bumblebee, to get in there to reach it. So you can exclude with structure. I think a lot from an evolutionary standpoint, it's easier to change that stuff maybe, because you see huge diversity in structure that can be very specific to a pollinator. But usually the nectar and pollen are fair game. I mean, there are some other toxic ones, no doubt, but I don't know of an example where they exclude a class. It's a cool question, though. One more question, anyone? Yeah, no, it's a fabulous question. So, I mean, what about seeds and germination and survival of these plants and climate change? And you see, again, a whole variety of responses. There are some plants that are able to move, if you will, not in their adult form, but in the seed form, pretty readily, and can even move quite long distances. But then you start to question and investigate dispersal strategies for various plants. And one of many examples right now that is worrying to people, again, has to do with the sort of specialties that evolve. It's these specialists that are really at risk right now from climate change. Some generalists too, because things are very unpredictable. But man, it seems like these specialty dispersal mechanisms are a bad idea at the moment, especially if when your disperser is gone. And so what we see with the Joshua tree, which in a few decades will be gone from Joshua Tree National Park. Joshua trees are these marvelous big yucca plants that have fabulous pollination strategy, which I won't get into, but they also have an interesting dispersal situation. If you look back over thousands of years in the fossil record and so forth, you can see that Joshua tree distribution changed a lot over time. So as climate conditions have varied, Joshua trees have been here or there all over the Southwest and down into Mexico at various times. It's left a fossil record. That's pretty cool. So we know that they were moving around somehow pretty long distances, because right now the only thing that really moves Joshua trees around are little rodents, little kangaroo mice that take it 20, 30 feet, something like that. And now we're in this situation where the Mojave Desert is changing rapidly, and conditions are becoming extremely difficult for Joshua trees there. Now, there are other areas that are becoming more suitable for Joshua trees. So, the people studying this think, well, somehow, when this happened in the past, if it happened this fast, which is questionable, but sometimes it changes pretty quick, they were going these long distances. How did that happen? How did it happen? How did it happen? And it wasn't until someone found this great cave in Nevada that is just full of dung from the Shasta giant ground sloth, which hasn't been around for 8,000 or 9,000 years. But if you look in the dung of the Shasta giant ground sloth, it is full of Joshua tree seeds. So that was the long distance disperser. You had rodents doing short distance stuff and moving Joshua trees around wherever they happen to be living, and that's all well and good. But if you needed to go a long way, you needed a ground sloth. The ground sloths are gone. Now the climate's changing rapidly. And even though for the past 9,000 years, Joshua trees have been doing just fine in a stable sort of Mojave, now that things are changing quick, they're in a world of hurt. Yeah. So again, when you see these sort of specialty situations, that's where the plants are going to have the hardest time keeping up with the changes in their landscape. Thank you all very much. This has been